Assalamualaikum and good day everyone. Alright, so we have learned up until theorem 2.2 which is actually on how to calculate for adjoint and how to calculate for determinant, and we are going to use these two calculation later on to look for inverse. So let's try to discuss on how to actually use the formula in finding the inverse for these two metrics. So let's start with A. So we are going to solve for A first by using this formula. Now we need to look for determinant, we need to look for adjoint. Alright, so those are the two things. But what actually the first thing that you need to look at? So remember that in finding inverse, you need to always look for determinant first, because determinant will tell you whether this metric is actually can be inversed or not. So just for a bit of revision, if the determinant value is not equal to 0, it means that we can find the inverse of this metric. Otherwise, if it is 0, then we will say that this metric is undefined. We cannot find its inverse. Okay, so let's proceed by looking at the determinant first using a cofactor expansion method. So looking at this column and rows, which actually the one that we should use, which row or which column that we should use. So alright, I will suggest you guys to choose for row number 2 in looking for the determinant, because of the element in row 2 consists of mostly 0. So basically it will actually later help us to facilitate us to make our calculation a bit easy compared to other row or column. Okay, so let's proceed with that calculation first using cofactor expansion. So this is this is the formula. So this is the formula that we need to use in finding determinant using cofactor expansion of the second row. So it is A21, which is the element of 1, or the element of 21, times with later on we'll calculate for the cofactor of 21, and then plus with A22 cofactor 2, and then A23 cofactor 23. So let's do that. So if we are to just substitute the element first, this is what it will look like. So we're going to have 3 times with later on the cofactor, still not be calculated, right? And then we have A22, which is 0. Okay, so this is actually the we still not calculated the cofactor yet, so just proceed. And then another 0. So basically what you can tell here is, now we have this as the first element, and for the second and third element, because it is 0, when you multiply it with whatever value that you have for the cofactor, it will still be 0. So basically, to calculate for determinant for this one, you don't need to calculate for these two. Right, you just need to focus on this one, because this will actually become the only value for the determinant because of the 0 here. That's why we choose row 2, so we can skip to do the calculation of cofactor several times. Right, so let's focus on calculating C21. So C21 is equal to -1 to the power of I plus j, which is 2 plus 1 times with its minor. What is the minor of C21? Let's look at it. So this is C, this is where A21 is, this is where C21 should be. So we exclude its row and column. That will leave us with this and this. So negative, so that will be its minor. -2, -1, 1, 1. So just proceed with the calculation. -1 to the power of 3 will be -1 times with the minor. Calculate the determinant of the minor. So we have -2 times 1 minus with -1 times 1. Right, which will give us, here is -1 times with -2 plus 1 will be -1. Right, so is equal to 1. So this is C11. Right, so for these two values it doesn't matter, because later on we're going to later multiply with 0, we will still get 0. So the determinant for this metric is actually equal to 3, right? So basically it can be, we can calculate for the inverse. So to calculate for the inverse, right, we already have the determinant. Next we need to calculate for adjoint, right? So basically for adjoint, the formula for adjoint is, if you can remember, is actually the inverse of the cofactor of each element. So basically we need to look for, now we need to look for the cofactor for each element. So let's do that. To look for the cofactor, of course we will start with A11. So A11, actually we should for C11, right, which is actually this part, right? Start with this. C11 equal to -1, 1 plus 1 times with its minor, which is 0, 0, 1, 1. 0, 0, 1, 1. So -1 to the power of 2 is 1 times with 0 times 1 and -0 times 1, so 0. So it is 0 over here, so 0. Okay, and then we are going to proceed for each of these element. So let's skip to it. So this is all the cofactor that we have calculated. You can pause the video to cross-check with your calculation later on. So now we have the cofactor. The next thing to do is to rewrite it as a cofactor metric. So how to write it down, the cofactor metric for this one, right? So it's actually equal to 0, -3, 3, 1, -1, 2, 0, 0, 0. This is the cofactor, and for us to find the adjoint, right, later on to use it in the inverse formula to find the adjoint, we know that it is with the inverse of the cofactor matrix. So the inverse of this cofactor matrix, which is we need to change row to column, column to row. Okay, so the adjoint for this cofactor matrix is, right, 0, -3, 3. The first row become the first column, so just put it like this, 0, -3, 3, right? And then we have the second row, 1, -1, 2. Put it as the second column. 1, negative 1, 2, and then 0, 0, 0 at the end. So this is the adjoint that we're going to use in our calculation of inverse. So we're going to put this metric up. So this is how it should look like, right, in our inverse formula. So 1 over 3, which is this determinant, times with the adjoint that we calculated just now. Right, so the next thing to do is to simply calculate the 1 over 3, right, times with all the elements inside. So we're going to have 1 over 3 times 0, which is still 0, and then this is become 1 over 3, and then 0. Next is negative 3 over 3, which is become negative 1. So next we have negative 1 over 3, and then 0. So 3 over 3, so we'll get 1, and then we have 2 over 3, and then 0. So this is the inverse. Now let's look on how to solve this second question. So of course, first we are going to check whether it is inversible or not by looking at its determinant. So which row or column that should we choose? Right, for me, the optimum one is this, right, because it's only consists of 0 and 1. So let's calculate for the determinant first. So as you can see, for this case, we have 1, 0, 1. So basically, we can actually just ignore this one, because later on 0 times with what is the value of the cofactor, it doesn't really matter, it becomes 0. So we will calculate for C21 and C23. So this is the cofactor for 21 and 23. So we have negative 1 and 7. So again, I didn't calculate this because of later on times with 0 will give us 0, so pointless. So I'll just calculate these two. So negative 1 is plus with 7, 6. So the determinant for this metric is 6. So it is inversible. So now that it is inversible, we are going to calculate the whole cofactor, right? I mean the cofactor for all elements, right? Because we need to find the adjoint. There you have it. The cofactor of all element. So let's rewrite the cofactor matrix. Negative 1, 1, 1, negative 1, negative 5, 7, 5, 1, negative 5. And then let's write the adjoint, which is the transpose of the cofactor. The adjoint for B. So negative 1, negative 1, 5. Remember, row become column, column become row. 1, negative 5, 1, 1, negative 1, 1. And then we have 1, 7, negative 5. Right, so this is the adjoint. Now that we have everything, we can calculate for the inverse of B. So 1 over the determinant, which is 6, times with the adjoint, so -1, -1, 5. Okay, so let's multiply it in. So this is the inverse of B. That's it for today's video. In the next video, we are going to discuss on system of equation. Thank you and Assalamualaikum.